Hi everybody, my name is Terry Minton and I'm going to be doing a presentation on facial recognition software for class CSC 342. The way I've structured this presentation is I'm going to give a brief overview of what facial recognition software actually is, go into a little bit of the history behind it, followed by the different types of facial recognition, then into some of the architecture behind it, followed up by, at the very end, the typical uses for it and what it might be used for. So with that said, what is facial recognition? I'm sure we've all heard it, have all seen something on TV about it, and possibly even used it in real life. You may have even used it and not even known. So basically what it is the facial recognition software is used for trying to automatically determine from a photograph or image or video frame that you give it, match it against a database of other images for an accurate match. And usually that is accompanied by some other sort of data with it, maybe names, numbers, serial numbers, addresses, something like that. So some of the history behind it. Facial recognition was pioneered in the early 60s by three people, Woody Bledsoe, Helen Chan, and Charles Bisson, who their main focus was to try to use a computer to recognize the human face. So what they just wanted the computer to recognize a human face, period. So some of the problems that they faced with that was that because of the huge database that it took to store the images in the 60s, getting it to go from 100,000 to 1,000 to 100 to 10 to one accurate match took a long time to process. The computers were much slower back then, so that was one of their major hurdles. Another one was it wasn't fully automated at that point. So users actually had to take the image, the photograph, find the characteristics such as the eyes, ears, nose, mouth, input those in, and then on top of that, measure the distance between the eyes and the nose and the lips and input that in along with the different aspect ratios. So it was a lot of manual processing just to have the computer recognize the human face to bring back a match. And that leads us to fast forward to the 70s. And so in the 70s, three different individuals used now 21, they came up and found there are 21 specific markers on the human face, such as the hair and hair color and lip thickness, to try and automate it. The problem was that they were getting it semi-automated, but the problem arose that you still had to take the measurements between the eyes and the nose and the lips and would have to input those ratios in to the computer to get a match. So we'll get a little further because now we're finding the hair color and the lip thickness and automating that, but you still had to take the measurements and get the aspect ratios for the program. So let's jump to the 80s now. Here is where the huge milestone was made because in the late 80s, there was a principle applied now to use linear algebra to calculate the distances and the ratios for the different characteristics on the face. So huge leaps and bounds to normalize the face using linear algebra. And now that leads us into the different types of facial recognition. What are they? So there's two predominant approaches to the facial recognition system. There is the geometric, which is the feature-based recognition, and then the photometric, which is view-based. So during this time of it all being pioneered and and figured out there was many different algorithms that I looked up. There was a ton of different algorithms developed, but there are three main branches that were studied to facial recognition, and those were the principal components analysis, or the PCA, the linear discriminant analysis, the LDA, and the elastic bunch graph matching, which is the EBGM. So those are what we're gonna focus on today. So let's start with the PCA, the principal components analysis. So what this did was the probe first normalized the image. So it would normalize it, it would line up the mouth, the eyes, and the nose, and then what it would do is it would start removing characteristics of the face that were non-informational. So anything that it would find as something that lower in priority, it would start removing to only narrow it down to the key features that it needed. So a sample image would be this. You take the photograph and then start removing non-key pieces to get it down to a very small set of characteristics that I need to match on to get an accurate match. And that's basically what the PCA does. So the LDA, the linear discriminant analysis. So this was more of a statistical approach for classifying unknown classes based on samples with known classes. So basically what this did was it would minimize the within the classes of each block, and it would deal with a highly dimensional face data against other blocks of images. And so you can see below where you have a row of images in a small block that were known classes against other larger blocks of unknown classes. And you would try to match on that row against another row of data. And that is the linear discriminant analysis, or LDA. Now the EBGM, the elastic bunch graphing matching, that relies on the concept of real face images that have non-linear characteristics. So this would take into account, we could see some here, outdoor lighting versus indoor, standing up straight versus leaning over, different expressions, laughing, smiling, frowning, crying, and try to use it based on that. And as we can see, the image below, it would try to pinpoint more on and take into account more of a grid-like, taking in all those other non-linear characteristics. And those are basically the three main branches of facial recognition. So let's look at some of the architecture. And obviously this looks familiar to what we've been seeing. So the image reader, the image reader module reads out a 20 by 20 image on this and this figure, and stores each pixel of the unknown image into the frame buffer. These pixels are of the unknown image that needs to be recognized, and then the previously stored pixels are sent to the normalized image calculator module in order to start normalizing the image calculation. So the normalized image calculator, it finds the differences between the average image and the input image. And then the input image pixels are subtracted to find the normalized input image. And then it's sent to the weight vector finder. So the weight vector finder module calculates the weight values for the input image using the previously calculated image in the eigenvector values. So the eigenvector values are read by the eigenface reader from the eigenface image buffer. And as you can see, it's moving along with the image and the address. And then the weight vector reader is used to classify the projection module for retrieving the weight vector values that are generated in the training stage. And that is stored into the block of RAM. And then finally, the classifier projection. The classifier module utilizes the weight vectors from the weight vector reader module and the weight vector for the unknown image from the vector finder module. So a lot of information in here that goes into identifying an unknown face. So you input the image, it then goes into the image reader, which is then passed to the normalized image calculator, which is then passed to the weight vector finder, which is then passed to the classifier projection, and then it outputs the face image of the identified person. And so that is basically the architecture behind what it looks like on the back end. So the pipeline, obviously we've just learned about this, the pipeline and latency. This figure that I found shows the latency of the implementation of the FPGA in milliseconds using both pipelined and non-pipelined implementations. So this shows the utilization of the RAM and the LUTs for both pipelining and non-pipelined implementations. So this is where we'll get our latency scores. Here's a couple more figures for you to look at. Some performance characterization comparisons between the software and the hardware. Obviously, the hardware has very low latency, whereas the software has higher latencies in milliseconds versus the number of images that it has to pass through. So obviously, the higher the number of images it has to sort through, the higher the latency in the software is going to be. Whereas you can see that the latency in the CPU or hardware is much lower. And then another figure down here, figure 5, that I show is the architecture for a complete facial recognition system consisting of face detection and the facial recognition subsystem. So you have the camera, and say it's just a normal facial recognition camera, or just a camera that's going to take a shot. Goes to the image interface, the RBG, the sync, and the control, to the face detection subsystem, which then makes the call to the down sampling, which then makes the call to the facial recognition subsystem, and then if a match is found in the person index, it's sent back through the downsampling up to the detection system subsystem, and then out to the DVI interface to a screen that says, hey, we have found a match. So you have a camera and then a computer sitting at the other end, and this is the normal route it will follow to detect a match on a, let's say this looks like it would be a video camera that takes a frame that you can pause it on a frame and run it through the facial recognition. So the performance comparisons, some brief overviews of this that give you some more accurate numbers, and obviously this one was taken of a Core 2 Duo running at 3.3 with 4 gigahertz of RAM, or 4 gigabytes of RAM, sorry. And then a brief description of the sampling and how it actually works. Obviously this is face of a 20 by 20 and sends its 400 pixel value to the recognition subsystem. And there again, the higher the pixel ratio, the higher the DPI, stuff like that, the more latency you're going to get, because the higher quality the image, the more pixels you get, the more features you're going to get, and the more accuracy. So we're coming up to the end of the presentation, and so the question I had was, which was actually a little bit funny, was who uses facial recognition software? Some of the big ones that you're automatically going to be thinking of, and possibly were thinking of in this PowerPoint, were the FBI. Obviously, the FBI uses it. A lot of local, that was the first one on my list. Law enforcement agencies, FBI, CIA, trying to find terrorists and stuff like that, definitely is using this software, taking images, and they have a large database to go through. Local law enforcement, again, they are using it, probably not in as broad of a range of the like FBI or CIA, but they might have the access to the databases that the FBI has. I don't know that for 100% certainty. The TSA is also using it now. They have been really trying to get on board with this to identify people passing through their gates and stuff like that. Here's one that I didn't even think about, is the ATMs. ATMs and check cashing. They're trying to use facial recognition to automate a lot of stuff. Now, when I first read this, I thought it was to, get burglars or something like that, or people that rob people at ATMs, but that's not necessarily the case. They are actually using it to automate your transactions and make it easier for the user to cash checks and use the ATM. Okay, this one was by far the funniest I've seen. Online dating services are now starting to use this. And there's another, I didn't put this up here because it was funny, but online dating, findyourfacemate.com, much different than Match or eHarmony that I've seen. They will actually take your picture and they will try to match it with someone who has the same characteristics of face you have. So you can do that as well. There's another one out there for Find My Pet. Find My Pet or Find My Pet Face. I did not put it up here, but you can essentially take a picture of yourself, scan it in, and they will try to match you against an animal that has the same characteristics as your face. I don't understand how I would want to use that, but Apple's trying to do this, or not trying. They are actively pursuing this and using this. There's applications out there that you can get that try to do facial recognition. I would nothing like what the FBI and TSA and CIA are using. They have, I'm sure, teams of people working on this. And then Google. Google is one of the ones that I found that were trying to use this. And I believe that's the last one. Yes, that goes into my references. But as you can see, and then you can see the references I used. Different websites, different documents that people have written. But it's very interesting. I want to go back here. If you're interested in facial recognition, I will tell you this. If you're interested in programming, as much as I am, you can go onto Code Project, you can go on to different sites, and they will give you some of the methods and even packages of functions and stuff like that to get it working for different, say you want to program for the iPhone or the Android or something like that. They actually will give you snippets of code for this. I highly suggest Googling uses for facial recognition because you will laugh. There is a lot of different uses for it out there that people it has been mainstreamed now to where people are trying to use this for everything. Taking pictures at the grocery store. It's not just for faces. It can be used for anything. It's facial recognition, but image recognition is also booming. So you can take a picture of your bleach bottle or water bottle or something like that and try to find it out there. So if you have any questions on facial recognition that I didn't cover in this PowerPoint, please feel free to email me. I do have a lot of extra documentation on it. There's a lot of documentation and a lot of studies out there on it. And again, there's a lot of code that's open source for you to use. And I'd be happy to give it to you. So again, my name is TerryMinton. I hope you like this presentation. And again, if you have any questions, please feel free to email me. Thank you. Good night.